Now, what we kind of really want to do is we want to start here at zeros, and then all zeros, that means it's stopped. And let's say we want to be stopped for a pretty good period of time. So now we know that our shortest period of time for turning right is 250 milliseconds. So that's the shortest period of time. So what we can do is we can make it go and step through each one of these steps at a 250 millisecond rate. And then when we want to go forward, we want 500 milliseconds, we'll just use two of these steps to make the 500 milliseconds. Okay, so is that going to still give us enough? I think that's still going to be enough. So let's try it. Let's hook up a 250 millisecond clock to a counter so that when the counter starts at 0, after 256 milliseconds it goes to a 1, and then it keeps counting at a 250 millisecond rate. Makes sense? So we're going to have a counter at a clock rate that matches the timing we want, and then we'll be able to control the outputs at that timing rate. So for now I'm going to cancel. Let's go get ourselves a counter. Oops. I forgot to get the 4 inputs. Okay. So let's go get ourselves a 4-bit counter. So here's a basic counter, and you can see already, good news, it's already 4 bits. We don't have to change it. We could if we wanted to, but we don't have to. We want a clock. Clock on the counter. We want a 250 millisecond pulse here. That's half of 500 milliseconds. 500 milliseconds is 2 hertz, or 2 cycles per second. So 250 milliseconds would be 4 hertz. So let's see if we can set this to 4 hertz. Okay, it let us do it. Like I said, let's go ahead and wire up our inputs. So we're going to go get a bus wire here. So you can see this counter output here is 3 down to 0. So that's 4 pins, 3 down to 0. So that's what's called a bus. Oops. So that's what's called a bus. So we're going to take this bus and we're going to run it down here. And now we want to wire up these inputs to this bus. And we want in 0 to be bit 0, in 1 to be bit 1, in 2 to be bit 2, and in 3 to be bit 3. So let's take this and wire it to the bus, and now double click on it. We are not going to use the computed name and width. We don't need a name for it. We're going to change it to a bit and make it bit 0. Okay, and there we go. Let's do the same for the rest of the inputs here. Double click it. Tick, 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 and this is bit 1. Output's wired up. So I'm just deleting each one of these. And then we're going to make forward output 0, reverse left, and right. All right. So we're going to clear this lookup table, and out 0 is forward. So we're going to start out maybe with a half a second of just doing nothing. And then we decided that we wanted to drive forward for 500 milliseconds. There you go. And then we wanted to turn right, which is out 3. So now we're going to drive forward and turn right for 250 milliseconds. And then we're going to stop turning right and drive forward another 500 milliseconds. Turn right again, drive forward, turn right again, drive forward, turn right again, and then stop. Now what's going to happen is, after it stops here again, the counter is going to switch back to all zeros and keep counting. So it will stop for a second, and then it will do the circle again. So let's go ahead and see if that works. Let's just program the car and turn it on and see what happens. So I plug the car back in, and we're going to compile. And there, it's all happy. If it's happy, we're happy. Now, let's see what happens. So I'm going to turn it on, and there you go. Let's take it out in the street and see what it really does.